While EF Core is pretty good at creating SQL for querying and persisting data, there will always be times when you want to use your own SQL, whether that's views, stored procedures, or even on-the-fly SQL. You've just learned a lot of ways to do this while still benefiting from EF Core's mapping, SQL execution, and object materialization. You learned about using the from SQL raw and from SQL interpolated methods to query the database using raw SQL and stored procedures, again, while still benefiting from EF Core's ability to materialize and track those results. Then you learned how to use migrations if you need to create new database objects like views or stored procedures. Using the migrations is a great way to keep your workflow consistent if you're already using migrations to apply schema changes based on your model updates. You learn about the keyless entities that allow us to have EF Core comprehend entities even if they don't have a key. Keyless entities let you build read-only entities that don't have key properties but can still be mapped to views and fully participate in queries with the EF Core. And then you saw the database execute SQL raw and execute SQL interpolated methods to execute non-query commands on the database through the DB context. I took advantage of this to finally show you a great option for deleting entities, but there's so much more you can do with these methods. If you're tired of working with this console app that we've been using throughout this course, I have good news. In the next module, we'll incorporate EF Core into an ASP.NET Core app so you can see how nicely EF Core integrates with ASP.NET Core. Here are links to resources I mentioned in this module and some others that I think you'll find useful. I'm Julie Lerman, and thanks again for watching Entity Framework Core Getting Started for EF Core 5. Hello, welcome back to Entity Framework Core 6 Fundamentals. I'm Julie Lerman, and I think this will be a fun module since we'll be building up a little ASP.NET Core application to serve up data with EF Core. Before digging into the code, I do think it's important to get a quick look at EF Core's lifecycle in disconnected apps, as well as to set some expectations for change tracking. Then it's to the code, where we'll add an ASP.NET Core project into our solution, where I've already included the domain and data projects that we built up over the previous modules. Then we'll add a new controller into that project, which targets the authors, and a Visual Studio template will do most of that work for you. Next, we'll need to wire up the API with the pub context. That way, EF Core can benefit from some of the great features of ASP.NET Core. And this also gives us a chance to remove some code that we won't need anymore. A really important lesson in this module will be to learn how to combine data transfer objects and entities in your controller methods. This will be an important refactoring of the code that's generated by the template. Along the way, you'll learn some tips for debugging and logging EF Core's work when it's in an ASP.NET Core app. Once all of that's set up, we'll rev up the controller and start doing some work with it. I also want to be sure that you're prepared for the fact that most of the demo will only involve authors. There are a lot more complexities when you start retrieving and persisting related data. You've already seen that in a connected app. Persisting related data has a lot of nuances. So we'll focus on the fundamentals here, and then you can add on to that with more advanced courses. The lifecycle of a DB context is different in web applications because of their disconnected nature. I think it's important for you to have at least some understanding of this before we start building an ASP.NET Core app using EF Core. So far in most of these examples, I've pulled down, modified, and saved data all at once while a single pub context instance remained in scope, tracking changes to the objects that it just retrieved. And that's a good way of getting an idea of how the change tracker works. And it's a good pattern if you're using an application that's totally on the client side, running on a computer or other device where the data is stored locally, or perhaps on a local network where the client computers have access to the database on a server that's on the same network. And we refer to the data access in these types of applications as connected. Another common scenario, however, is when the user interface is disconnected from the back-end logic where the data is managed. For example, you might have a website that interacts with a web service or a web API. The service can't share a DB context instance across all of its web users, so each method to retrieve or update data will instantiate its own DB context instance and then dispose it when it's finished. Then, on the next request, it will create a brand new controller, which will create a brand new DB context. In the web scenario, after an object is retrieved, it gets sent across the internet. It's impossible for the context that's in memory on the server to know what's happening on someone's browser anyway. So there's really no point in keeping the DB context in scope. This also gives us an opportunity to improve query performance, since there's no need for the context to waste its time building up those tracking objects. It's a perfect scenario for no tracking queries, but even better, you can just define the context to be no tracking by default. And when you send objects to your web application that need to be persisted into the database, the new DB context instance won't have any clue about the history of that object. So it becomes your job to make sure that your code is able to inform EF Core whether an object needs to be inserted, updated, or deleted from the database. As you've seen, we do have a number of ways to do this, with the dbset methods, add, update, and remove, or setting the entry state explicitly through the context, or even just pulling down the current values from the database and applying the incoming values to those objects directly. But all of these patterns still require that your web application knows what the state of the incoming objects should be. And to be clear, this isn't an EF Core problem. It's an age-old problem, or at least a computer age-old problem for any disconnected application, regardless of what technology stack you're using. But as you're here to learn the fundamentals of EF Core, we'll take the most common path to solve that problem. And of course, you can learn about the more advanced patterns as you move further along your journey. We'll be building up this solution in stages to make the lesson more clear. And the first thing, of course, is to create an ASP.NET Core project. You can create a number of types of applications with ASP.NET Core, and all of them rely on some type of API on the server. So rather than worry about or commit to a front end, we'll just build an ASP.NET Core API and interact with it directly. I've created a new solution where I've copied in the data and domain projects from the previous module. A lot of demos will put the domain classes and DB context into the same project as the ASP.NET Core app, but keeping the logic of the data concerns, the domain concerns, and the ASP.NET Core concerns separate is much more realistic and the pattern I prefer to teach even if you're just getting started. With these two projects already in place, I'll add a third project, an ASP.NET Core app, into the solution. And I'll give you a quick walkthrough of creating the Web API project in case you've not done that before. But this is definitely no stand-in for learning how to build ASP.NET Core Web APIs. Be sure to select the ASP.NET Core Web API, not Web App. I'll click Next where I can provide a project name, which will be Pub API, and specify the location, although I don't need to change that location. Then we'll go to the next screen, where you can choose the framework and other attributes of the project. And most of the defaults are correct here. Configure HTTPS is checked, but that will add a layer of complexity for our demo. And that complexity has nothing to do with Entity Framework Core, so I'm going to uncheck it. And that's it for creating the project. I'll definitely want this new project to be the startup project in the solution, so I'll go ahead and make that change. Looking at the project in Solution Explorer, you'll see a controllers folder and a few files. One of those is appsettings.json. That's a place to specify some configurations for the app. Program.cs is the app's starting point, and it contains logic for what happens as the application starts up. If you've built ASP.NET Core apps in the past, you might be surprised that there's no longer a startup file. The logic of the startup is now woven into the program file. The template provides a little sample to generate weather forecast data. There's a weather forecast class and a weather forecast controller. An important point about this project is that if you open up the CS file, you'll notice that it's really minimal. There's a project SDK attribute, which is set to Microsoft.NET.SDK.Web, and a target framework attribute, which is set to Net 6.0. And there's only one NuGet package referenced for something called Swashbuckle. Having Swashbuckle in the app will let us explore the running API without building a front end. Swashbuckle wraps a pretty cool tool called Swagger that's used by web developers across all of the different web stacks to test out their APIs. The project template created everything we need to go ahead and run the app. Since I'm on Windows, I can debug this locally in IIS Express or use the .NET Core server called Kestrel, which is just represented in the debug dropdown as the name of the project. And it's the default, so I'll go with that. Remember that the API doesn't have a front end, but it does have that tool I mentioned, Swagger, built in so that you have some way of testing out the API in the browser. So by default, when you run this from Visual Studio, it redirects you to the Swagger interface, which displays the API methods, in this case only one, a GET method. But I'm going to go around Swagger for the first few executions, since it does provide a lot of information, and if you've never used it before, it can be a little overwhelming. I'll replace Swagger index with the name of the API, Weather Forecast. And as a result, here's the JSON that's output by the API. Now, the API outputs raw JSON, but I've got a Chrome browser extension called JSON View that formats it, so it looks pretty and it's more readable. And there are plenty of extensions to do this in various browsers. So that's what we get by default, and it's running and working, and we can move ahead.